My name's Charles Garvey. I'm the CEO of Metabolomic Diagnostics. We're attempting to predict early in pregnancy complications that women may encounter, and in doing so provide information to clinicians so that they can tailor the care to the actual risk profile of the woman. And the biggest kind of risk during a woman's pregnancy is actually a disease called pre-eclampsia, which is a nasty disease. It still kills about 75,000 women every year. It kills over 500,000 babies every year. And it's not rare. It affects about 5% of first-time pregnancies. And at the moment in a first-time pregnancy, there's no real indication of who's going to get the disease.
So I'm Robin Turton. I'm a Vice President of R&D of Metabolomic Diagnostics. A single biomarker won't be able to predict or diagnose preeclampsia because it is like a conglomerate of pathways. So to encapsulate the full syndrome, you need probably multiple biomarkers. And that's where we are working on, and that's where we think LC-MS is very interesting to use. One of the considerations we made when we were starting our translational research process of getting these putative biomarkers and try to translate them in robust tests is okay, how are we going to do this? So we made a decision at the level of sample prep, ideally as minimal as possible. We have thus far chosen and been successful to use a simple protein precipitation. The second choice was okay, what kind of LC we're going to use? So we could opt for nano LC or capillary LC because you can get a lot of sensitivity, low consumptions of volumes. But in real life, if you think robustness, clinical laboratory, it's throughput, it has to run all the time. You don't want problems, you want standardization. We have a 1260 series of the pump, which is very robust, and we have that hyphenated with either a 6460 triple quadruple, equipped with an Agilent Jetstream electrospray source, and then the other instrument we use is a 6495, also enabled with an Agilent Jetstream, and which also features the ion funnel and the more optimized ion optics. And both instruments deliver what we need, but the 6495 compensates more for our lack of optimization up front. They are very robust. They can take good flow rates, and we can use standard columns and not use for nano LC or so, which is far harder to standardize if you think forward in operations, in big operations. We also try to source in as much knowledge from outside, and we are very fortunate with Agilent because sometimes we have application chemists coming in and they work together with us on our problems at hand, so it enables us to focus on what we want to do. We don't have to develop all this knowledge all the time ourselves. Agilent people have to, in fairness, they are very open to share.
Agilent's been an excellent partner. When we were getting set up, they provided technical expertise to come in and work with us for a few days and assist us in learning more and speeding up the work. What we aspire to longer term is to use the platform and a sample taken early in a woman's pregnancy initially to risk stratify for pre-eclampsia. But there are lots of other complications in pregnancy, and we believe metabolomic profiling is the key to risk stratifying for far more than just pre-eclampsia. Our ambition, I suppose, would be to develop a panel of tests, all based on a single specimen taken at a single time and analysed by our algorithms.